And welcome to Climate Chat. I am your host, Dan Miller, and with my co-host, Leon Simons. Welcome,
Hi.
Leon. So today, we're going to do something a little different. The sort of normal schedule for interviews is a little different. So this week on Tuesday at 10 a.m. Pacific time, we're going to have Caitlin Ramey, who is a professor at the University of Michigan, and she studies public perceptions of climate change and climate solutions. You know, what do people think of carbon capture and solar radiation management, and what drives their thinking about climate change? It's going to be a really interesting discussion. I heard her give a talk last week and invited her on, and but she wasn't available on Sunday, so we're doing that on Tuesday, this Tuesday at 10 a.m. Pacific time. And there will be links following the show posted on Twitter and on Bluesky and LinkedIn as well. So today we're going to do something I don't think we've done since the Clubhouse days when we weren't on YouTube. And that's an Ask Me Anything, or in this case, Ask Us Anything show, where we're just going to answer questions that come on the chat. We have Stacy going to help us look over the chat. So if you do have questions for us, please preface your question in the chat with the word question, : so it'd be easy to spot, or at least cue : so we can just separate the questions out from the general comments. And I have some questions for Leon as well, and he has some material that he wants to go over as well. So, Leon, did you want to start off with the question from Zeke Hausfather? Well, they're not a question from him, but his. Yeah, right now, by the way, there's 100 hours of weather and climate live stream happening with literally hundreds, like 100 or 200 climate scientists, weather scientists. And they're doing 100 hours, and I think there's another day or so to go. I listened to one of the programs with the Zeke Hausfather, who we interviewed on the show, and you can look that interview up. Really, very interesting. You're
Sorry.
trying to add that video, or?
Yeah, or can you see it already?
No, I cannot.
Okay.
So let's see.
I and a few other
Click
scientists.
on video and see if you can add it.
Sorry.
Oh, okay.
Sorry, you continue, and I'll start it.
Okay, so this is a little clip from that presentation that Zeke gave during this live stream where he's talking about acceleration. So let's listen to that.
A few other scientists have argued that some of these CMIP6 models might be running a little too hot, which is why one of the reasons why the IPCC's estimate is a little lower than the sort of average across all the latest climate models. And folks who are interested in that can find more details in a piece in Nature that we put out 2 years ago now on sort of the hot model problem. And then finally, there was a paper that got a lot of attention 2 years ago by Dr. James Hansen. And he and colleagues argued that we'd see a roughly 50% increase in the rate of warming, which is shown by that shaded area in the bottom right. And so generally speaking, no one really expects the historical rate of warming since 1907 to continue unchanged. And so the fact that we have seen an apparent speed of warming doesn't necessarily mean it's worse than we thought. It doesn't necessarily mean that we're outside the range of what our models expect. And so it's important to keep that in mind.
Okay. So what do you think of that, Leon? And I should point out to folks who don't know, Leon was a co-author with James Hansen on that breakthrough global warming in the pipeline paper from a couple of years ago now, so he has some authority to speak on the subject. So go ahead, Leon.
Yeah. So I just want to point out that he gave a great presentation. I think it's important to know that there's this 100-hour live stream, and there's these I guess 100 or 200 scientists presenting their research and highlighting the importance of of research, and that's not just climate research, but of course climate research is also an important part of the research that's now being attacked by the United States government, and they're trying to break that down. And Z gave a very insightful presentation. So of course we like to go into the details here, and I don't want to split hairs here, but I think it's good to go back to this discussion on acceleration, and I think one important thing that Zeke mentioned here, in this, of course, it's a bit of a cherry pick from everything he said, which was most of it was quite insightful, and but this one point where he says that there's no one expects the continuation of the linear trend, and I think that's. I was quite surprised to hear him say that, because of course over the past years, and still many are saying that there is no acceleration, and let me share my screen to show you what it was like in 2023 before the data of the year 2023 and 2024 came in. Then many were saying, like, let me show you data. So here, Ryan made a thread here, where he highlighted who said there was acceleration in 2023 and who didn't say, who said that there was no acceleration. And here I just collected some of the people that were saying that there was no acceleration, and some were saying, it's wrong to say that there's human-caused warming is accelerating because of El Nino. Of course, that I think that's an important point. Of course, there was El Nino, and then of course then temperature goes up. But this is really a great example of a strawman argument, where we say, because we were predicting already this acceleration before all these monthly data, which were really record-breaking, came in. And here even this May 2023, and then we hadn't had these extreme months of September, and of course these. Now we have, if you look at the ECMWF Aero 5 data set, we have now 2 years. On average, there were 1.6 degrees Celsius. So for 24 months average, it's 1.6 degrees Celsius above the pre-industrial baseline. So that has nothing to do. Of course, there's some El Nino in there, but there's also La Nina in there, right? And then, so there were many of these arguments saying, look, it's not going. It's
oh, it looks like there's a pause.
There's a pause even, right? Or there's no acceleration yet. Or Zeke himself said at the time that CO2 emissions are flattening, and that there shouldn't be any acceleration based on that. And of course, you can look back at the models and say maybe the models did show some acceleration, but some were calling it cherry picking, but we just presented the data, and it's not just us. I always highlight that, but it's not just James Hansen and the co-authors, including me, saying that there would be acceleration, or there is acceleration. It's NASA, it's NOAA showing with the data there's increased heat accumulation, and that indicates that now there was a doubling of the global heat uptake. Of course, we should expect acceleration based on that, because if you put more heat into a system, whether it's an oven or a planet, it will heat up. And if you put more heat into a system twice as fast, it will heat up much faster. Of course, the temperature will go up much faster. It's quite basic. So we did expect acceleration, but yeah. So looking back to 2023, there were quite some voices saying, that they did expect acceleration. And of course, we said that there would be acceleration, or there was already acceleration. And our peer forcer also said, okay, the forcing is increasing, so that's what indicates there will be acceleration. And Glenn Peters said the same, using this is the same data, but just a different way to present it. Here's the decadal trends. Here's from 70-50. I'll get to that later. And here even Lane Cheng et al., which includes Michael Mann, they published a paper where they improved the data set they were using for the ocean heat content, and now it does show acceleration. Of course, even one of the co-authors doesn't like to acknowledge that, but I won't go into that too much. But I think that's important to highlight that I don't think everyone expects that there will be acceleration or that there is acceleration, let alone acknowledge it publicly. And of course, now the science is quite clear now, right? If you look at the published science, it says there's a robust acceleration, and a very recent paper with all these co-authors, which are really the people. Many of these names, they are on the forefront of research in this area. They show that the Earth's energy imbalance has more than doubled in recent decades.
And that's the thing that causes the warming. It's the fact that there's more energy coming in than going out. So that's what makes something warm.
Earth's energy imbalance is indeed how much heat is going.
I'm curious about Zeke's comment, though, because it was only 2 years ago that he said, according to this here, that the temperature is not accelerating. And now he's saying it is. Do you understand how is it just updated research? I think what's changing his mind, or
what we see a lot happening in, and I don't want to hate on Zeke here, but I think, of course, he now acknowledges that there is acceleration, and you could say, okay, if you just look at CO2, and that's what he does here, right? Just looking at CO2.
Right, just looking at CO2. Okay.
As CO2 forcing, the CO2 forcing is increasing linearly. So just based on the CO2 forcing, there shouldn't be any acceleration. And that's what many do, right? That's what many do. They say, right, okay, just looking at, and then that's also with these net zero arguments that there will be no more warming if we reach net zero. Many of these publications and many of these argumentations, they ignore the other greenhouse gases and aerosols. So if you just
true.
If you pretend there's just CO2 and nothing else matters, right? And so you could say, okay, this is a somewhat accurate statement in a way, but if you see if you have been following these discussions, we were really like ridiculed, and if you see these other arguments, you spoke to Jonathan, and he was like, those people who say that there's acceleration, they don't know what they're talking about. They're not part of the consensus. They are fringe, and many have been saying that for years. And now we get these arguments that, of course, there's acceleration. That's what the models have been showing all along. And I think that's quite, you can always say, okay, look, this model shows linear warming. This model shows, and that's also what Zeke pointed at, is like so you have these hot models which were excluded, and some now like to include them, say, oh, maybe we should include them, and then the models were right, or then the models are fine. And I think that's, that's not really,
it's a science evolving, but I think it's important to note that if you listen to the full presentation by Zeke that you showed 1 minute of, it was like 15, 20 minutes long. He does emphasize in the presentation that a lot of the acceleration is coming from aerosols. Now, of course, I think he looks at aerosols a little differently than you and Jim Hansen does, but he does emphasize that a lot of it's coming. He emphasizes the reduction in aerosols from China in his presentation, and says shipping is also something, but he thinks it's less, obviously, than what you and Jim think it is.
I think let's get to that in a minute. Let's just finish this up, because I think this is quite this is the IPCC report on 1.5 degrees, and this is what many policymakers and also some climate communicators base their estimates on when we will reach 1.5, or and that's just a linear extrapolation here. This orange line, and these are like if we would reduce CO2 to zero within starting from 2020 to I think that's between 2040 and 2055, right? Of course, that's not happening. We didn't continue to reduce CO2 at the same rate that we did during COVID, right? Year on year, another 5 to 8% reduction. That's not what happened in the real world. So we shouldn't look at these other trends anymore because it's not what's happening, and that's not what will happen. I don't think anyone believes that it will happen, but this linear increase is also not what's happening. Because then we would reach 1.5 degrees Celsius in 2040. And then if you hear the same data or the same model here, this range shows the IPCC, and here is 2040, and then this is the ECMWF era 5, and we see, if you use a 30-year linear trend, of course, all the recent months were above the trend line, even during a weak La Nina.
Mm-hmm.
And then we would reach it in 2029, and we will be now at 1.4. And I think and if you would look at a nonlinear trend line for 30 years, we would already be at 1.5. And I think that's important if you use a 15-year trend. So it really also matters like how you extrapolate it. If you look at a 15-year extrapolation, we would also now be at 1.5. Of course,
there's nothing to require the temperature to go up in a linear fashion, right?
Sorry?
There's nothing that requires the temperature to go up in a linear fashion. We're trying to fit straight lines to this data, when it certainly looks by eye that a nonlinear fit of the data would work much better, like what you're showing right here.
Yeah,
this just looks by eye to be a much better fit to the data. Because when you do the straight line, you have to take a straight line for part of it and a different straight line for a different part of the data.
Yeah. So here was linear. Like you can say between 1970 and 2010, it's linear, and but then there's no reason to assume that it will continue linearly. It's quite the opposite, because we have the data. We understand that aerosols are reducing. We understand that greenhouse gas emissions keep increasing. We understand that the concentrations over the recent years have been increasing at record rates of methane and of CO2. And aerosols are rapidly decreasing, especially over the ocean. So, these basic understandings would predict there will be acceleration. That's also what Zeke pointed out now. And then and then we have all the data from the satellites and from the ocean heat content, where we see also that there's more than a doubling of heat uptake. So of course we should see acceleration, right? There's no reason why it should continue linearly.
And just for everyone who wants to go into this more, we did a show on exactly this, on when will we hit 2C a week or two ago. So you can just go back in the archives there and watch that show, where Leon goes into much more detail on when we're hitting 1.5, which is now, and when we might possibly hit 2 and even 3. It's part of the discussion.
I think that's the next question also. Like what temperature increase this is Stephanie Ross asked me that, and of course, let me just read it out loud. So question: what temperature increase does James Hansen predict for 2050 and onwards? Is there realistically any way back from the increases, assuming we don't have a sudden global agreement and everyone stops burning fossil fuels and the CO2 level keeps going up? So there's there's like 3 or 4 questions in one. So I think, so we don't do predictions, right? And of course I can't really fully speak for James Hansen, but what we published in 2023, Zeke mentioned, was a 50% increase, but what we published was a 50 to 100% increase. So from 0.18 degrees Celsius, so doubling, or will be 0.36. So and that's then per year, but that might be an underestimate. right? Because that was public. We wrote the paper in 2022. We included some feedback during the peer review process, but we didn't have the data yet of 2023 and 2024. And what we're starting to see now that there's the acceleration. If you look at these numbers, where it is what from there's a preprint from Grant Foster and Stephen Rumsdorf, where they showed that if you look at the different data sets, we see an average increase, a rate of one where they correct for natural variability of the sun and of the volcanoes and from El Nino. They see a warming trend of 0.43 degrees Celsius per decade, which is above our estimate, right, or our estimate of the increased rate of warming from what we published in 2023. And of course, as it says, it might reduce, but it might also increase further, right? Because also, if you look at the Earth energy imbalance has more than doubled. So why wouldn't this rate of warming more than double? It might even be more, right? So then if you look at, of course, it very much depends on what happens to greenhouse gases and aerosols. I'll get to that in more detail later. But so I think last week or the week before, someone asked like if I could extrapolate when we would hit 2 degrees. So the data from this preprint just showed for 1.5, but I just extrapolated it to higher thresholds, and then you see like if this rate of warming, so this is quite high, of course, but not impossible. If the climate sensitivity is high and we continue to add greenhouse gas and reduce aerosols, I think this is not impossible. Then we could reach, about let's say 3 degrees by 2060, and so the question was about 2050. So about 2.5 degrees by 2050, and without reducing greenhouse gas emissions significantly, of course, it will just keep increasing. It will not decrease if you don't decrease the greenhouse gas concentration in the atmosphere, not just emissions, but you have to really, the concentration would need to go down for the forcing to decrease and for warming to decrease.
So I have a question for you on this, and this is a question I had about sort of the whole idea of a step change in aerosols, like the IMO 2020 rule change, where boom, just 1 year to the next goes down 80% in the amount of. So when you have a step change, and I think I know the answer, but I'm going to leave it for you. You think of it as being a one-time thing. Okay, it's going to increase temperatures right then that year, but from then on, assuming you don't fool around with aerosols anymore, I mean, of course you might still, but assuming you don't, then you should be back to the linear trend of the greenhouse gas only. Now, so why is that not true? Why does a change like the IMO 2020 have a longer term impact on acceleration than the 1 year when it actually happens?
Yeah. So there's different things involved. So you have the natural variability, of course, but so if let's assume it's 0.5, right? Wait, let me just go here. So maybe to show you, and I've showed this before, but here's like the 130,000 year trend of CO2 equivalents relative to 1750, and so if you go back, these are just greenhouse gases, not including aerosols. I've shown them before, including aerosols, but then you see that we have never been like this high at all in millions of years. Probably this is on 30,000 years, but we are probably now maybe 15 million years ago is the last time.
And certainly, humans only been around 300,000 years or so. So
yeah, humans
certainly since humans walked the earth. Yeah,
and like how long we have been cooking food, that's some debate about that, but maybe 1 million or maybe 2 million years in different ways. So there's nothing like this. Humans have never experienced anything like this. And then so this is the greenhouse gas forcing, right? And then there's the aerosol forcing, and here this hot off the presses, but it's not, the update has not been published yet from Forster et al. From Piers Forster, where this is the update of the IPCC greenhouse gas and aerosol forcing estimates using the same methodology as was presented in the IPCC. Let me make this full screen so you don't see you still see the bottom. So here the top red line shows the greenhouse gas forcing, again over 4 watts per square meter, which is more than a doubling of CO2. Of course, this is not just CO2, but it includes all the other greenhouse gases, the forcings. And then there's this aerosol estimate, so how much cooling was caused by air pollution. This is their estimate total, so that's indirect and direct effect, including clouds. And then the net effect in blue, where you see this combined. So of course, if you add aerosol cooling to this red line, the red line will be lower, and then it's about here. That's the IPCC estimate, but they don't show a very strong increase after 2020 from the shipping emissions. But now here I've added James Hansen, his estimate of about 2 watts per square meter shipping forcing, and I use so it's a bit technical.
0.5.
Sorry.
I'm not sure what you said, but 0.5 watts per square meter.
0.5 watts per square meter forcing. So that's very strong effect. So that's really a high estimate compared to the other estimates, as Zeke also mentioned in his talk. But that and it's a bit technical, but I use here a logarithmic correlation between the shipping emissions and assume a 20 million ton background load of sulfur from algae, because there's a natural emissions from algae as well, which also put sulfur over the oceans. And then you see this big increase, and that also translates into an increase in the net forcing, of course, which is not visible from the IPCC estimates, which uses simple climate models. And then in this glowing yellow line, that shows the absorbed solar radiation, and this shows outgoing infrared radiation, which is negative, which means that there's more heat going out of the system in the infrared. But it doesn't. But there's much more heat being absorbed, which causes the increase in absorbed solar of the Earth's energy imbalance. So yeah, that's really that's the biggest difference, right, between the IPCC and our research. Right?
But I believe that part of the answer to my question, though, is that any forcing change plays out over a very long period of time with the ECS, equilibrium climate sensitivity, because there are feedbacks, and there's feedbacks to even changes in aerosols. And as Hansen points out, the first third of those impacts happen in the first 10 years, and the next third happen in the next 100 years, and then the last third happen in the next 1,000 years, even for something like an aerosol change. Isn't that right?
Yes. And aerosol is more certain, right? Because, of course, most of this is based on greenhouse gases. And our estimate, I think what we published in 2023 wasn't solely focused on aerosol forcing and what the response time for that will be. But, basic understanding of what happens in the ocean. If you reduce, for example, air pollution over land, of course, the ground heats up very fast, and it radiates heat back to space very fast, much faster than the oceans. And the oceans accumulate 90% of the heat of global warming. So global warming is mainly ocean warming. And then if you reduce air pollution over the oceans, it will take a long, long time for this effect to fully translate into warming. And then if you have warming, then that warming will also, of course, start to increase the outgoing long wave radiation. So, and that will try to stabilize the climate. That's the Planck feedback. We've talked about that before. But then that warming will also cause a reduction in ice, because if it's warmer, ice will start melting. And that, of course, also, as we discussed, reduces cloud cover, and less clouds or higher clouds, that also cause an increase in how much sunlight is absorbed by the oceans. And
And water vapor too. More water vapor.
Then now we get to the step. So of course, like it doesn't have to keep accelerating, but it also it very much depends like on if this forcing change is permanent, and so you could say no, this warming, this acceleration is permanent. When and it might not be when we assume that methane will decrease and sulfur emissions will stay flat or will not decrease much faster. So it really depends on all the other forcings, not just on and on the feedback. So it's really, let me say bye to someone. What was that?
What was that?
Sorry, that's my daughter.
Oh.
Sorry. Yeah. So it really depends on the forcings and on the feedbacks, and we really haven't seen this. These maybe I still have one more graph here. Let me check. Yeah. So this, it's still increasing, right? The imbalance. This is 4-year averages of the same data I showed here. The top is absorbed solar radiation, and the bottom is the increase in outgoing long wave radiation. So here's twisted through. And then this band is increasing still. There's no, it's not stabilizing. So maybe it stabilizes, but and that's also an important answer to the previous question, which I read, that we don't know, right? We're just getting the data, and we are really in uncharted territory, completely uncharted territory. As I've said before, there's never been an experiment where a planet the greenhouse gas forcing of a planet was increased by 4 watts per square meter in 2 years. Half of that was masked by aerosols, and then very rapidly those aerosols were reduced, right? So of course we have climate models and we can try to run that, but we are only the data, the observed data, which of course the best model we have, what's happening in the real world, that's only starting to come in, and it looks like there will still be a lot of warming in the pipeline based on this data.
So I think we have so many questions in the comments so far. I think we should kind of move to a mode where we start answering them and also keep it quick because there's just so many. So rather than going into detailed answers, if something requires more, then I think we can spend some time. Maybe I'll take the first one here. So let's go to this mode here. Let's turn off that. Let's see, remove. Okay.
Let me stop sharing.
All right, so there we go there. And so I'm going to. Stacy is ready, I think. But so let's bring. Wait. I got to move to here and invite Stacy. Hi, Stacy.
Hey, Dan. Hey, Leon. And I was about to say uncle to YouTube. There are so many questions here.
But I was going to take the first one because I see it here, and it's like it's actually the first. It is literally the first one. So let's pop it up. Have you read Derek Jensen's Bright Green Lies? So I haven't read the whole book, but I did study it, and I kind of read reviews of it and saw summaries of it, and also the critiques of it. And this is basically saying something that I wouldn't say that renewable energy is a scam. It's just we're not going to solve climate with renewables because they have so many problems, and they go into the problems. And so my answer to this would be all forms of energy have environmental impacts. So that's not really the question. This book, I believe, is sort of suggesting that our only solution is to essentially go live in a cave, reduce energy demand tremendously and just stop using energy because it all has terrible impact, like fossil fuels, terrible, and renewable energy, terrible. But I say they are not the same. Renewable energy has far, far, far lower impact than fossil fuels. Not saying it doesn't have impacts. It does have negative impacts. But and just think of it this way. You do all your mining and you make your renewable solar panels or wind, and then they produce energy for 20 years without further inputs. Whereas with fossil fuels, you dig them up and you burn them, and then you dig them up again the next day and you burn them and you dig them. And so just to compare, so a car which has 20 pounds of lithium in the battery, roughly, something like that. And of course, the car has lots of other stuff in it that has to be mined. And you're driving that. And let's assume you're driving in California, where most of the energy is coming from relatively clean sources. If you want to compare that to a fossil fuel car, you have to imagine that you're driving next door, driving alongside of you is a 4,000-gallon tanker truck filled with gasoline, because that's how much your car is going to burn over its lifetime. So when you really look at it that way, you can see that while, yes, renewables have environmental impacts, they are far, far less than fossil fuel impacts. And they throw climate change in and all the other stuff. There's really no contest. Now, is it better if we just shut down using energy somehow? It depends what you mean by best. I mean, many people will suffer and die if you do that. So, but it will maybe help the climate more than trying to maintain our level of civilization. I'm not, we had William Rees on here talk about how we're overshooting everything, and it's not wrong. Okay. But unless you're going to propose how we're going to get the world to scale back its energy use to, a tiny percent of what it is today, then I'm not sure how helpful that is. So that's my quick take on bright green lies. So what do you have for us next there?
Well, so dovetailing into that, there's related questions around civilization collapse and peak oil. Are these our only hope? Wait,
what was the first part? I didn't hear what you said.
Sorry. Civilization collapse and peak oil, those types of things. So are, my lovely Thanos cure of we get rid of, well, at least the half that are doing the bad things anyway. Is that the only way we're going to be able to truly combat climate change? By
having civilization collapse? Well, some people think that. Well, again, there's some people that think that's inevitable. I wouldn't say they say that's the way to do it, but they say it's inevitable. I just had someone tweeting at me yesterday about that. But we also had Elliot Jacobson on, and there's some people who believe that's a good thing to have civilization collapse because humans damage nature, the rest of nature, the non-human side of nature, so much that if we got rid of humans, then nature could thrive. If that's your point of view, I'm not going to disagree. I mean, obviously, you can come at it in a different way. But is it possible? Maybe the question really should be: is it possible to address climate change without civilization collapse? Maybe that's really the question. And I think the answer is yes. But we have to switch from, so far, choosing to fail, as climate scientist Kevin Anderson puts it, to choosing to succeed, right? So far, we're choosing to fail, right? We're not really doing anything to address climate change. So to say, well, it's not working. Well, what's not working? We're not doing anything.
Right.
So if we do things, what would those things include? So one of the things it would include is, rather than just hoping that renewable energy takes over from fossil fuels, we would put policies in place that require renewables to take over from fossil fuels. Very different thing. Right now, we're subsidizing renewables and we're ending up with lots of renewables, but we're not ending up with less fossil fuels. Be a very different story if there were policies that require the phase out of fossil fuels over very short time frames, relatively speaking, decade, 2 decades, 3 decades, different kinds of energy. Electricity is easy to replace. Cars are easy to replace with EVs. Heat for steel and cement is harder to do, but can be done. And you put policies in place that require that. So first of all, you end up with one, rapid emissions reduction. Okay, that's step one. And step two, what you would have to do is, we already put 2.6 trillion tons of green CO2 into the atmosphere. We've emitted it. There's about 1 trillion tons that stay up there. The rest in the oceans, land, and soils get absorbed. But we have to actually back off on that because CO2 levels are already way too high. They're 50% higher than they used to be. Throw in the other greenhouse gases, we're already at a doubling. So that's too high. So we have to remove them. And it's going to take time and money to do that. And so in the meantime, if we don't do anything else and only focus on emissions reduction and removing carbon from the atmosphere, then we're definitely going to fly over 2 degrees, we're going to pass tipping points, and it really won't matter if we do those other things because we're going to be past tipping points like AMOC collapse and Greenland ice sheet and West Antarctic ice sheet. So, so the third thing we have to do is then cool the planet using sunlight reflection methods. And that would give us time to do the other 2 things, because those 2 things, even if you did them aggressively, you really wouldn't notice any difference for decades. I mean, scientists could measure them, but you're not going to notice that things getting better. If you're lucky, they'll stop getting worse. But even that, I have a question for Leon about that. So anyway, so so if we do those 3 things and we get serious and choose to succeed, then yes, we have a chance to address climate change without civilization collapse. But Leon, I want to ask you a question that this is related to. Many people say, Michael Mann, this is one of his favorite sayings, that if we get down to 0 emissions, then temperature increases will stop. And the quick reasoning on that is that while there is warming in the pipeline, as your paper shows, if we had 0 emissions, then the oceans would continue to take up CO2, just like they did last year, because they don't know our annual emissions, they only know the total, and there's an overburden of CO2 in the atmosphere. So they would continue to take it up at roughly the same rate, and that would lower CO2 in the atmosphere, and those 2 would cancel out. Methane would cancel out with aerosols, and you'd end up with no temperature increase. But all of that, I believe, assumes a 3 degrees equilibrium climate sensitivity, and as you and Jim Hansen came up with, it's looking more, well, according to Jim Hansen, it's more like 4.5 degrees. Is that whole scenario of warming stops at net zero go out the window with a 4.5 degree ECS?
I just want to point out that you start with a lot of disclaimers there and a lot of hypotheticals, and people know that. Most people here know that, but that's, I think, quite important to mention that, there's this instant human extinction scenario where we reduce aerosols and but also reduce methane emission and CO2, but that's not what the person you just referenced refers to. They refer to this: only CO2 goes to 0 and everything else stays the same. Let's ignore everything else. Yeah, that's what the paper.
I thought emissions go to 0.
Only CO2 emissions go to 0, and the rest stays the same, right? Or wow. the rest. Let's not discuss that, or let's ignore that. We assume that they even each other nicely out, but okay. So that's either the instant human extinction scenario, because I don't really care about these hypotheticals. I care to understand first, what does that look like in the real world? Because you're asking me, what would that look like in the real world? Well, asking me a question about this like thing that would never happen in the real world, right? So it's a bit so because when would we reach that point? If we would reach that now, when the planet is at 1.5 degrees Celsius, that would look very different than when we are maybe at 3 degrees Celsius already. And well, how are the CO2 concentrations? Or in the real world, are people still eating rice? Or are people still eating meat? Or is this like how many greenhouse gases that have a lifetime of thousands of years are there, like these chlorofluorides, right? So it's just too hypothetical for my liking. Right? Of course, okay. we publish it, but yeah, it's always like you can point me that. Like if you have to give me, if I would have to give an answer, I don't think so. I think if the climate sensitivity is as high as it looks like, and we are already seeing the sinks of the Amazon and the boreal forests over Canada and Russia that are starting to turn into sources rather than sinks of CO2, and of course we would also reduce all the other fertilizers. Currently, we emit 2 times as much, so we've tripled the land nitrogen cycle. Okay. And that fertilizes also how much CO2 is taken up by the biosphere and by the oceans. So you also have to take that into account, right? So it's okay. It's just yeah.
All right, let's move on because we got to keep it quick per question.
Okay.
because we have
So going to the next level of that, is it possible that we can solve these questions? Is there a Green New Deal that could be reached in a capitalistic society?
Well, I think if, again, that gets back to choosing to fail versus choosing to succeed. Within a capitalistic society, and by the way, I'll mention like non-capitalistic societies are polluting the world a lot, so it's not just that. I mean, the humans are doing a good job. I think it is possible, but it's obviously not happening now. I mean, that's for sure. So maybe, and if the climate shocks get our attention enough and people get scared, as they appropriately should be, about the future and want to do something to change it and demand from their elected leaders that they do serious things, not the things we've done in the past. Again, subsidizing renewables as opposed to phasing out fossil fuels is just one simple example. But if we get to serious policies and the three things I mentioned earlier, then I think it is possible. Now, it's possible. That doesn't mean we're going to do it. So far, we're not doing it. Let's be clear. But again, the world is not going to be the same in 10 years from now as it is now, and certainly not the same 20 years from now. 20 years from now, we're over 2C, which is fucking crazy. So if we do get scared enough and begin to implement serious policies, then I think there's a chance.
What do you think about the IPCC and the political and corporate influence there? Is there any way that can be reversed, or do we just start ignoring IPCC?
It's inherent, right? There's an inherent, like the government. It's an intergovernmental panel on climate change. So the influence of government, especially for what's presented in the summary for policymakers, that's inherently controlled by the governments, which include Saudi Arabia and India, where I've talked about it before, where they say we shouldn't talk about aerosols. We shouldn't put that into the summary for policymakers. Let's just pretend that it doesn't exist because it's too inconvenient. That's almost literally how these discussions are held. Right, the notes are there. I'm not really exaggerating. Say let's just not include that, because people might want to do it on purpose or whatever. So I think, yes. And I don't think really we there's a lot of good science in the IPCC, but you have to take it with a grain of salt, and you have to understand because it's in a way it's just a summary of the science that's there. And if you want to stay up to date of the science, you don't have to read the IPCC reports. You have to read the science, the recent publication, try to understand what it says.
Okay. Oh, and I do want to put in a brief interstitial comment here for that. Earlier we were talking about Zeke Housefather's comments, and I think you probably mentioned it, Dan. We had him on a year ago, and the whole topic was debating the acceleration debate. And so I would encourage people to go back and watch that, because I mean, I won't call it flip-flopping. I will call it evolution of thought. But I'm glad that he has come around on that.
I think Danny already was quite clear about acceleration.
He what?
He was quite clear that there was acceleration, and some misrepresented what he said, that there was no acceleration, that there was only acceleration starting from 1970. But at that time, Zeke was already acknowledging that the data was showing that there was some acceleration. I think that's, and then he was also including these models, and I think that's to me that's where often, and it's not just Zeke, but that's what I often see. Some, like, you can say, if I make now 3 predictions for the next year, say it will be cooler, and one time I say it will be the same temperature as this year, and one time I say it will be warmer. I will always be right, right? Because I was right at the time here, and I gave 3 scenarios, and one of the scenarios was right, and I think that's a bit what's happening often, where if someone wants to say, look, the IPCC models are correct, they exclude they include the hot models. If they want to show that we are not at 1.5 degrees yet in the models, they include the hot models so they exclude them. Sorry. So and if they say want to show it linear, they show this IPCC 1.5 report, right? So there's always a lot of scenarios in IPCC. You should look what the IPCC said here. They were right, but here they said something else, right? They said so many things in those 4,000 pages of each single report, right? So
yeah, but I did catch. So while you guys were talking at the beginning, I did a quick scan of the interview, and he said something to the effect of, well, there's a discrepancy between, the ocean heating that's going on and what EIA says, or something. I don't know, something like that. And he was basically like, yeah, we don't know what to make of that yet, But I'm pretty sure we had him on for the premise of he was not into admitting acceleration, but I could be wrong. That was my recollection.
So I think that was before 2024 happened or ended.
Yeah.
So there was 2024, of course, opened some more eyes or made it more clear for those who mainly look at global surface air temperatures that there was acceleration.
Yeah.
But if you look at the NASA data and you look at the ocean heat content data in detail, you already saw it coming from for many years, and that's and we know that will cause faster warming. We see it, and that's really basic physics, right?
Right.
Put more heat into the system faster, the temperature will increase faster.
Okay, and so I wanted to go to an earlier question of Greenland and Switzerland have had permafrost thaw triggered fatal catastrophes over the past decade. Is there any reason to think these will cease in the Alps or in Greenland?
What was the last part of the question?
Is there any reason to think these will cease in the Alps or the Greenland?
No. It just happened last week, and
Yeah.
It was really amazing. A whole town got totally wiped out in Switzerland because the glacier at the top of this huge valley, and the glaciers at the top of the mountain, it just gave away and covered the town completely. And then you look and you see there's little towns up and down that valley, and they're all high peaks there anyway, and it's not gonna. Yeah, that's not going to stop. It's going to accelerate. That's what's going to happen.
Yeah, so here it came down, and it was someone shared this, and I estimated how much mass came down from this Swiss glacier. It was over 1,600 Eiffel Towers worth of mass came down. But that's that's a lot. But if you compare that to Greenland.
Greenland is huge.
So every hour, Greenland ice sheet loses 30 million pounds.
That same amount?
No, twice
as
much.
It's not the same
as we saw. So every hour, Greenland loses as much ice as came down here in this single event. So it's, this is a lot, but Greenland loses much more. There's a lot of mass. Every hour, such a big ice cube worth of ice melts off of Greenland.
Let's keep going.
Yeah, this just popped up from Frosty again, and it was asked earlier. Is it true that parts of Canada, the Canadian fire right now, had not burned for at least 10,000 years? I don't know if that's something you guys know about.
Quite surprising, because fires, I don't know. Fire's sort of a natural, but they don't go like this. Maybe certainly a fire this big. What used to be, you used to have little fires that would burn the underbrush and leave the trees. And that's, in fact, if you go to the Sequoia National Park, in California, you learn that those trees require fire in order to grow. In other words, they have to sterilize the soil with fire, and then they can the trees can drop the seeds in, and then the trees can grow. So and their bark is fireproof, right? It's fireproof stuff in the bark. And so that's the way it's supposed to be. But these fires are like a whole different thing. This is, in Canada, the conditions for fire this year are insane, and it's already happening. So there's other questions we got in the previous chat. I mean, in like Twitter about that, and asked what's going to happen, what's the short term and the long term implications of these fires. And certainly in the short term, there could be some cooling. You have all those aerosols, but the long term is that it's releasing a lot of carbon stores. These carbon sinks that are becoming carbon sources, and so overall pretty bad. And then the other really big thing I just read this morning that Greenland is having the surface melt across its entire surface because of the fires. These fires, drop black carbon, little black specks everywhere they go. And if they blow over the ice, they drop, like black specks on the ice, and those black specks absorb more sunlight than the white ice does, the reflective ice, and so that accelerates warming. So it's all in all not a good thing. Okay.
I just want
to. Do you want to? You have this up here. Do you want to say something, Leon, about this?
Yeah, because I saw a question. I'm not sure if I can find it, but I think they asked about Greenland, or sorry, about the Spanish heat. I think that Spain is now experiencing temperatures. So this is Spain, for those who don't know. This daily sea surface temperature. But Spain is now experiencing temperatures of close to 40 degrees Celsius already in May. And there was a question about the heat there. But I think that what I want to show, I also want to show is that this enormous increase in sea surface temperatures around. So there's the Mediterranean, there's the Atlantic, here's the North Sea. And there's, of course, last week, someone was asking if we can already see the continued desulfurization over the Mediterranean, which started on May 1st this year. Of course, that's because there's a lot of variability. It will be hard to see data within such a short period of time. But it is, I think, very worrying that we see so much heat around Europe. We really have to get ready for a lot of extreme weather again this year in Europe for this summer. I just want to point that out, and it will take a while before we get more data from what the effect is, both from of course every period we get with more data also on the global impacts, but also for the Mediterranean. It will take a few months or years to get more and more data to see what's happening there, including from satellite data to see how clouds change and aerosols change. So I've answered a few questions in one go here.
Yes. So this one is really interesting. And Dan, here, I'll give you a time. We often hear that there can't be infinite growth on a finite planet, but the system isn't completely closed. Solar radiation reaches us, so can growth continue without destroying the climate?
I'm sorry, let's see. The system isn't completely solar, so we can, well, I think it's a different kind of thing. You're talking about growth of extraction and destruction of the thing. So let me give you an example. We have GDP growth, and they target like 3.5%. It's like that's considered pretty good GDP growth. Not incredible like they get in China sometimes, not low growth. So let's just assume civilization started 3,000 years ago. Let's say somewhere in China, civilization started, and they said, hey, let's have GDP growth of 3.5%. So, and back then, the entire world only made 1 cubic meter of stuff. That was the entire production of the Earth back then, 1 cubic meter of stuff. But it grew at 3.5% every year. Then the question is, how much stuff would we be making today? And the answer to that, the question would be, would it cover the surface of the Earth? And the answer is yes, it would cover the surface of the Earth out to the orbit of Neptune. and not just a disk, but a sphere. So a sphere the size of the solar system, okay? Which is insane, and obviously not going to be done on Earth. And that is what infinite growth on a finite planet actually is. So when you say infinite growth, you're not just talking about linear growth, you're talking about exponential growth, because you want it to be 3.5% more each year. And that creates what's called doublings. And you have enough doublings, you're going to end up with a very large number. So the answer is no, you cannot have infinite growth on a finite planet. Could you have infinite linear growth? If you just slightly improve things, yes, you could last a lot longer that way. But you just can't do it. Exponentials are not your friend. People don't understand exponentials. They catch you when you're not looking, because they don't look bad for a long, long, long time, and then all of a sudden, zoom, they zoom up. So, so that the answer is no. You can't have infinite growth on a finite planet.
This one is about a chart that Leon
It's gonna have a lot of growth.
That Leon showed about the Earth energy imbalance, and it was thrice as high as 25 years ago. So does that mean warming is also 3 times as high now? That it is now about 0.5 C per decade?
I'm not.
Yeah, that could be. That's of course it takes a while for this heat, so for this heat to translate into higher temperatures. So we see now that the rate of warming has more than doubled and potentially tripled. So in this data set, of course, we look now what I shared. I think it was from 0.4 to 1.4, and of course that's even more than tripling. But that's just from one data set, and there's some uncertainty, so it might be even worse, but it might not be that bad. So it depends a bit on the data set. I think there's quite some worrying signs. So the two, I think, quite most reliable and also quite scary data sets are this NASA Ceres satellite data, where they look at how much energy comes in and is reflected, and is going out from infrared radiation. So really the energy imbalance, how much heat is going in and out. And then the other one is where they look at global sea levels, and also at what contributes to these global sea levels. And then they show that there's much more sea level rise due to the increase in heat in the oceans. Because there's uncertainty in how you measure all these these different points, and there's not no observations over the poles, or and less observation in the less deep oceans. That's why this global sea level data is quite important also. And because it takes 50 times as much to increase the sea level by thermal expansion than from melting of land ice, that also is a quite important indicator. If there's more due to thermal expansion, that means that there's more fast heat accumulating faster. And that's so two of these very important lines of evidence show that there's a doubling, or even more than a doubling, of the rate of warming of global heat uptake. And that, of course, that it would I think it would be logical if that leads to even more than a doubling of the rate of surface air temperature increase. And what we showed in our Shukman et al. Paper in 2023 was that the rate of atmospheric heat uptake has quadrupled already. So the heat in the atmosphere, so in the whole atmosphere from ground level to all the way to space, and that includes temperature, but also how much water vapor is in the atmosphere. That rate has quadrupled. So yeah, so that I think there's quite a lot of indications that we should prepare for at least a more than a doubling. So 0.4 or 0.5, we should prepare for that, and much of that will be over the northern hemisphere mid latitudes over the next decade.
Okay, we have another question here on insurance. How will all the disasters affect the insurance industry? I don't know how it survives even with reinsurance, et cetera. Well, yeah. So insurance, it's interesting. The insurance industry really has to pay attention to science. Politics doesn't work for them. So they can't just say, well, climate change isn't real. They're going to go out of business, if they do that. So they are taking it seriously. They are canceling insurance in places like California and Florida, where either fires and/or hurricanes, are really impacting them. And then state regulators try to say, well, I'm sorry, you're not allowed to increase your insurance rates that fast. And then they say, okay, goodbye, we're leaving. And then they pull out. And then what's happened in both Florida and in California is that the state steps in and sets up its own insurance company, essentially, to fund the insurance that people can't get otherwise. And that works for a while, by the way. And eventually what it happens is that I read once that if this one particular hurricane, which I don't remember which one it was, in Florida, hit like it did and caused the damage it caused, and if all the homes were insured with the state insurance fund at that time, which they weren't, only a small percentage were, then it would have cost more than the total budget of the state of Florida, not the insurance budget for the state of Florida, the entire budget for the state of Florida. And so you can just see that part doesn't work. And what that means also is in the future, it means governments will have to step in more and more and selectively choose which disasters to help with. And it also means that we're going to be, bottom line, suffering more, right? There will be more damage that doesn't get rebuilt and things like that in the future. And that's just the way it's going to be because, we're choosing that path, and we want it to be here's the one point I really have been making a lot recently. The status quo, which is sort of how we've lived our lives and how we've run our civilization and insurance and everything, and we want that to be the future. We want that status quo to continue into the future. Unfortunately, it's not one of the options we have available to us. So either we get serious about climate change and make the change. This is the point Kevin Anderson makes all the time. Either we make the changes, which includes revamping the insurance system, but also, of course, reducing emissions, removing carbon, and doing solar radiation management. And the costs involved in that, and it actually saves a lot of money if you do that, but it disrupts certain industries, so that's no longer a status quo for them. So that's it. The status quo is not one of the options. So you can pick the other ones. You can pick total disaster if you want. If you want to pretend that the status quo is going to continue, then you can do that and not do anything to address climate change and the other planetary boundaries and take what comes. But the bottom line is insurance is going to be, the government's going to step in more and more for a while, and then we're going to have to figure out other ways, which is going to be basically having things uninsured. And it also will mean the other side of that is that things will be built to withstand fire and flood and things like that, far more than they were in the past. In the past, you could just pick up cheap insurance in case it did get wiped out. So in the future, you're going to have to build it to make sure that doesn't happen. So a lot of changes are going to happen in the future.
So in short is like the industry will be fine. They will just move out of regions where they cannot. They will lose more money. Some disasters are nice because they will have an excuse to increase the insurance rate, and then if the disasters are too big, the government, the regional or national governments will step in anyway. Yep. So the insurance will always make sure they stay on top. So I think they're
otherwise they won't be around to insure anybody if they can't make money.
Yeah, exactly.
Yeah. Okay. What else, Stacey?
I wanted to ask this one wild card question that I just find, kind of fascinating. Now, where did I put it? It's theoretically, if a big fat solar storm like the Carrington event of 1859 strikes on Earth and puts down most electric-based infrastructure and stuff for at least several years, what would happen? What would happen for climate warming? warming, sorry. And if it continues, what about everything else? So.
Well, it's interesting because there is a solar storm heading our way at this exact moment. I just read this morning.
Yeah.
Like it's supposed to be a G4. Carrington, I think, is G5. But and there was one last year? There was a G5. So there was a Carrington size event that happened. But the systems, I guess, are, they know they're coming. They can prepare, and it didn't have much of an effect. But assuming it had even a G6, if there's such a thing, and it really wiped out the electric grid, that would lower emissions for a while, but maybe also increase them as people just started burning
stuff
in sight, to stay warm and whatever. So, it would be obviously highly disruptive. And we built just imagine like just not having your iPhone for a day. How disruptive that feels to somebody right now. I don't know. We didn't have iPhones when I was growing up, and we were fine. The same thing now with electricity, the internet. So the internet goes down for a few days where you are totally, you're going to feel really affected. Where again, that didn't even exist, 25 years ago or something. And then, and obviously electricity, we're very used to it. Didn't have it at all 100 something years ago. But anyway, it would be a big deal. I don't know the climate impact exactly. I think that probably have a short-term climate benefit, but maybe not in the long term. I don't know. Interesting question.
Yeah. Okay, here's one that's sort of, why is the scientific community not really honest with the problem? Arrhenius in 1896 predicted 4 to 6 degrees Celsius with a doubling of CO2 or GHGs. We are now on this way to collapse.
Well, Arrhenius, did a calculation based on 1896, based on the information he had. It was amazing how close he came to being right. I heard it was actually closer to 4, but Celsius. But he also didn't think it would be a problem. He thought it would be a good thing because he lived in Sweden, and a little bit of warming would be a good thing. So they didn't really understand everything about. And he wasn't saying that this is going to happen soon. He thought it would take like 3,000 years to double CO2 at the rate they were putting CO2 out back then, right? That's the other thing about exponentials. You keep going up, and you can really get things going, happen much faster than you thought otherwise. But I mean, in any case, ECS is somewhere probably in 3, 4.5, 5 degree range. And the data I've seen from Leon and Jim Hansen suggests to me that they're right, because they're not doing it one way. I mean, we covered on the program a couple of weeks ago, just from solar dimming and nothing else. And that just measured directly from a satellite, that the Earth got 0.5% dimmer in the last 25 years. Just from that alone, you can do the calculations and say ECS is very high, because essentially you can tell that the cloud feedback is quite high. But they didn't just do it that way. They did it through the change in the ship smoke, and did it that way. And they did it by looking at paleoclimate and looking at models. I think 4 different ways, 5 different ways, and all coming up with high ECS. So the answer is probably is high ECS. By the way, you should assume there is high ECS. Maybe that's the right way to put it, because when you're dealing with existential threats, like if you're not sure how many bullets are in the chamber when you're playing Russian roulette, just assume it's the maximum number and pretend that's what it is. And that's probably the best way to deal with it. So anyway, so Arrhenius, amazing that he did that. He wasn't worried about climate change at the time he did it. It was a interesting thing. Hey, we're burning coal that releases CO2. That'll warm the Earth. I wonder how much the Earth warms if we double CO2. And then he came up and he did a calculation and got it, roughly right. And that was the first global warming paper written in 1896. So these people that say, there's a whole new thing that scientists have come up with,
Nope.
they're wrong.
I think there's a bit of a confusion here. So it seems like there's that the science is saying that we, for example, are not yet at that we can still stay below 1.5, and I think that's very few are saying that, right? So if
that's
you,
another question you're addressing, right?
yeah, but I think can you read the question again? Because I think not just about the solar or the.
Oh,
I think,
Arrhenius.
sorry, wasn't the question also about
What's the
why?
question,
Um,
Stacey, or did you lose it
oh, I
already?
moved it down. Okay. Why is the scientific community not really honest with the problem? He
Yeah, that's the point.
predicted 4 to 6 degrees Celsius with a doubling of CO2 or GHGs, and we are now on this way to collapse.
Yeah, so that's what
Okay,
I mean.
then
So what is the science honest, or like the science, the science is what does science mean, right? It's, I think there's many scientists being very honest about us reaching this enormous level of greenhouse gases, that we should be at below 350 parts per million, while we are at 420 parts per million CO2 and 560 parts per million CO2 equivalents, right? So, but and they've been trying to be honest about that for decades, but like nobody's listening, and often the media and the public, they also want to hear some positive news. So some of those who are less honest get more attention. But I think the people who are doing all the research and really try to understand what the data shows, which I already also showed you this research and all this, where the data clearly shows this acceleration. The data clearly shows that the CO2 concentration is very high, the methane concentration is very high, nitrous oxide concentration is very high, aerosols are rapidly decreasing. We are experiencing rapidly accelerated warming, and we will likely experience rapid sea level rise too, and have to adapt to that. I don't think that, like, the science is quite clear, right? The science itself doesn't lie. It's people who lie.
Okay. By the way, unfortunately I just lost one of these questions, but from to be generous, a climate skeptic, shall we say, rather than a climate denier, and it was, and I just lost it. It just went off my list, so I can't show it. But
Oh,
it
I've got
basically
them.
said,
Just tell me.
yeah, I know, but
Yes.
I can't display it. But it basically said, hey, people have been saying the ice caps are going to disappear. They've been saying the sea level is going to rise, and and some were saying that there was going to be an ice age, and therefore I don't believe any of it. Well, let's address those. First of all, the ice caps have shrunk an incredible amount. They're down 70%, I think, in the last 35 years. The volume of sea ice in the Arctic has dropped by 70% in the last 30, 35, 40 years. So the answer is yes, they are shrinking, and eventually, you wait long enough, they're going to disappear. So that one is actually true. I mean, it didn't happen as fast as some people thought it would, and then perhaps it's like happening faster than other people thought it would, but and certainly happening faster than she thinks it's happening. So that one is true. Sea levels, are they rising? Yes, they are rising. Then they are accelerating in the amount they are rising. It's gone up, I think, 8 inches or so in the last century, which is a lot for the whole effing ocean. and it's going to go up much higher this century than that, with kind of regular conservative predictions of a meter. But if you listen to Jim Hansen and say, hey, we have an AMOC collapse, the water stays around Antarctica, speeds up its melt, you look at the exponentials and you could have several meters of sea level rise around the end of the century, maybe a little bit after that, but still several meters is more than 10 feet. The entire southern third of Florida is no longer on the map. It doesn't show up on the map at that point. And then, of course, island nations and coastal cities are just devastated. So that one's true, too. And then the last one, they used to say there's going to be an ice age. Well, in the 1970s, there were some articles, including a cover story on Newsweek, saying the coming ice age. And therefore, people thought that scientists were saying we're going to have an ice age. Well, first of all, we should be heading to an ice age, but we're not. And back in the 70s, the vast majority of scientists said, no, we're going to have warming, not an ice age. There were There were some, just in the scientific community, there's always disagreement, and there were some saying, no, that ice age is supposed to be coming, still.
But it was cooling because of all this air pollution. There was regional cooling.
Yeah, there was regional cooling, and until the 70s, when we passed the Clean Air Act and started getting rid of these aerosols, the smoke that was reflecting the sun, and that's when the temperature started going up steadily. So that whole meme that scientists said there would be an ice age in the 70s, and therefore you can't trust anything scientists said, it's BS. Let's call it what it is.
But let's really break her brain by explaining that with the ice melt and the eventual AMOC collapse, that there will be an ice age in parts of the globe.
In Scandinavia, you're gonna have your own little personal ice age.
Yes.
Yeah, and the other denier points are there was something called the Little Ice Age that happened, and there was, it was a regional cooling, and there was the medieval warm period, which was a regional warming, but the ice sheets were not growing like it was, like it wasn't a real ice age or anything like that, and then also it was hotter, they say, in the 1930s, but that's not true. It was hotter. And it wasn't even hotter. It was really hot in the U.S., contiguous U.S., in the 1930s, called the Dust Bowl. And but the U.S., the contiguous U.S., the lower 48 states, is only 1.6% of the surface area of the globe, which is kind of a mind-blowing thing when you think about it. You look at a map and you see the United States like that. But start off and realize that 2/3 of the globe is water. So all the land on Earth only is 30%, all of it. And now the U.S. is not it's a big country, but not the biggest country, and it's about 1.6%. So the fact that 1.6% of the globe was warm back in the 30s when the rest of the world was much cooler does not prove that global warming is not here. Anyway, I was hoping to get a lot more of the denier comments, but we got a few. So let's keep going.
One from Nadia. Is the event that's been set in motion on par with the Permian Triassic, or does that idea rest on feedbacks as of yet not incorporated into models, etc., or not yet deemed large?
So the mass extinction, yeah.
Yes.
Well, I was actually just tweeting about this yesterday, in fact. So 252 million years ago, the Earth rose 6 to 8 C over thousands of years. And this had to do probably with some volcanoes that were like continuously spewing CO2, not just like a one-shot thing like we have now, but like a continuous set of volcanoes, or some other natural factor that increased CO2 rapidly and caused a 6 to 8 degrees C increase in warming suddenly, again, over thousands of years. And that caused 90% of life on Earth to perish. It was the greatest mass extinction in the record, and we're heading up to 3 or 4 degrees this century, but all in a tiny fraction of the time it took. And I think to answer her question is no. Scientists don't like to look at that. You don't. In fact, we don't really. Scientists don't really look much past 2100 in terms of looking at impacts of things, right? How much warming we're going to get, when it comes to sea level, actually, that's one where they talk over hundreds to thousands of years, and they'll sometimes give you a number based on that. But that's really it. You don't really, I haven't seen much on comparing the current warming to past mass extinctions, except in general, people talk that we are in a mass extinction right now, which is true. The back extinction rate's about 1,000 times what the background extinction rate normally is. So that's happening, but that's really quite different than 90% of life on Earth perishing. I think it's useful to say, though, that the stuff Leon was showing earlier about the rate of warming per decade, and that the fact that those models show that we would hit 4C of warming by the end of the century, before the 2080s, I think it was. So we've had climate scientist Kevin Anderson on, and he said in 2010, and when I asked him this question, he updated the 4C to said probably closer to 3. But back then in 2010, he said 4C of warming is not compatible with an organized global community, which means collapse of civilization. It's devastating to the majority of ecosystems, including our own, but all other animals and plants, and is beyond adaptation. So it's not like you're going to turn your air conditioner up and be okay. And the last one was probably not stable, because at 4C of warming would lead to 5C of warming, through feedbacks and things. So that you would be on this treadmill of going higher. When I asked him about that last time he was on the show, he said, yeah, from what we know now, that was 2010. It's probably closer, 3C is probably that number. And we're going to be in that in 2050. Let me say that within, the lifetime of our children today, and not even like particularly old if they're born now, when they're 25 years old, kids born today will be dealing with a world that's in the range of 3C warmer than pre-industrial, which
hasn't been there for millions.
Unless we do solar radiation management, which I predict we will do by then, because we're going to get sick and tired of all these heat things and also the tipping points. And we realize it's $5 billion a year. It's the cheapest thing we could do. And even though there's incredible resistance to it now because people don't like us screwing around with the climate, we should have thought of that a couple hundred years ago before we started screwing around with the climate. But anyway, let's move on. We got so many questions.
Yeah, in fact, so I don't know if we have a Jean and we have a Jean R or Jean. I don't know. No one's told me. Although one of them did say, oh, it depends on which country you're in. But anyway, Jean R has a series of great questions. I'll go with the first one that is kind of a new concept to me. What do you think about the EROI, energy return on investment, which has been declining sharply in recent years? Will society still be energy sustainable?
That's a good question. So energy return on investment means how much energy do you need to make new energy? And it used to be a very, the return, the amount of new energy you got for a given amount of energy was very high when we were just sticking a pipe in the ground in Saudi Arabia, Texas, and just pumping oil out of the ground. And it didn't take a lot of effort. But now we're fracking, and now we're doing deep water drilling. And so now, tar sands, it takes 3 barrels of oil to make 4 barrels of oil, right, in the tar sand. So the energy return on investment for fossil fuels has been dropping rapidly. At the same time, renewable energy is getting more and more efficient. Battery storage, throwing out batteries for a moment, but solar panels are very efficient and very cheap, and they're making them more and more efficiently all the time. And so that's actually, even though it used to be thought that renewable energy was far below fossil energy when it comes to EROI, it turns out if you take a look at the recent data, it shows that, and I just had to look this up just last week, that renewable energy now has, on average, because it's totally different, still in Saudi Arabia, the EROI is very high for oil there, but just overall, renewable energy has a higher EROI than fossil fuels, which is good for society because it means as we switch to renewables, we'll save lots of money. It will generate, and also the other side of it is that like half of, at least a third, but it might be a half of all fossil energy is wasted as waste heat. When you put a gallon of gasoline in your car and you burn it, the very first thing that happens is you lose half the energy right away from the heat. And there's many other reasons you lose energy in your car on a gasoline-powered car. So only 10%, I understand, of the energy in a gallon of gasoline moves your car, and 1% moves you, by the way. But when it comes to, but I think it might be 20% efficient, so let's call it that. A battery electric vehicle is 90% efficient. You put the energy in, and 90% goes to turn the wheels. So it's not wasting energy to waste heat and things like that. So EROI is now a positive thing for renewables. So there you go.
Okay. And so I thank you, Jean. It's Jean. Since aerosol regulation, we observed an acceleration of global warming, 0.45 C per decade. Here you go, Leon. How long will it take for the hidden warming to be real? How long will this accelerated rate last?
Yeah, so that's the $1 million question, and I think that's so. I'm honestly quite surprised that the energy imbalance is still increasing. Of course, it's a bit hard to see with all the variability, but if you look at the 4-year average, you see especially this level of absorbed solar radiation is still going up. And of course, there was variability, and if there's an El Nino, we would expect it to increase a bit. I know there's also this cycle in the Pacific Ocean, but this cycle is called the Pacific Decadal Oscillation, has been negative for the past 5 years. So we don't know how much connected that is to the shipping emissions, but it might turn positive, and that's if that turned positive, and that would increase further the rate of warming, right? Then because it's not just a question about how long will this take, but also how strong is the effect really? Because if the natural variability has been decreasing the imbalance in the past years, the effect of these aerosols might be even stronger than we now think based on the data that we have available now, right? Because we still because of all this fluctuation, this noise in the data, you could call this you call the weather, you could call it variability, you call it noise. It's quite difficult to see with just a few years of data what's the signal, what's really what's the evidence, and so it will take a few years before we know, maybe a few decades. But yeah, I'm quite because this area, right? If we would without if the energy imbalance is about 5 watts or 8 watts per square meter, then you would expect the rate of warming to be back at about 0.18 degrees Celsius per decade. But if it's 1.4 and it stays this high, then we will have a very long acceleration, and of course higher temperatures, and that will cause all these tipping points, which could cause even more acceleration. So doesn't really answer the question, because and in a way, I was thinking about it recently, like, is there how certain can we ever be about this, right? There's this chaos theory. I don't know if people know the 3-body problem. There's this I think there's a series on Netflix where if you have this, I don't want to spoil it for people, but maybe you should close your ears if you just still want to see it. But there's this, if you have a planet and there's like 3 suns around it, it's because of all the interactions with the gravity and the uncertainty. It's impossible to know what the climate will look like centuries within years or centuries, right? But maybe that's the same on Earth, right? There's so much uncertainty within the climate system. How do algae respond to warmer sea surface temperatures? How do ecosystems respond? How do forests respond? How do humans respond? We don't really know, so we cannot really predict what will happen this century. There's always uncertainties. So yeah,
Okay.
don't expect anyone to tell you what will happen. We just have projections.
Okay, this one. OMG, Chad. Dan answers this all the time. Why does Dan continue to ignore the carbon needed to create that car, solar panels, windmills, batteries, you name it? He doesn't. Go on, Dan.
Yeah, well, as I said, all forms of energy that we know of have environmental impacts, whether that be EVs. And by the way, while EVs are far better than fossil fuel cars, they're way worse than bicycles or walkable cities or public transportation or any of these things, as we've talked about many times. And so the question is not Do they have environmental impacts? Yes, the answer is they do. The question is, but what are we comparing them to? So if you want to go around saying that EVs and solar panels are terrible, we shouldn't have them. Well, are you first going around and getting rid of all the fossil fuel cars before you say that? Because compared to fossil fuel cars, they're way better. Again, not good for the environment. And when you really look at the impacts they have negative impacts. Yes, they have negative impacts. The negative impacts are far, far less than those from fossil fuels, which even on just a car basis, as I mentioned, you have your 4,000-gallon tanker truck driving alongside your car, and that's how much you're burning. That's how much weight of stuff you're burning over the lifetime of that car, which is a huge amount. And you had to mine that stuff, and so you had all the negative environmental impacts from that. But then you leave it as CO2 in the atmosphere, will last for up to 500,000 years in the atmosphere, causing damage. So, there's just no comparison. But yes, these things have environmental impacts for sure. And that's why I think we should have policies that phase out fossil fuels and then allow renewables to replace them, as opposed to making renewables really cheap and subsidizing them. And then you just end up with more renewables, not less fossil fuels, more renewables with their, again, smaller but still substantial environmental impact. And so you end up with a negative environment. You didn't lower fossil fuels, and now you just have a lot more of this other thing. That's not the way to do it. The way to do it is to phase out the fossil fuels and let renewables infill them, and then things would be better, still not good, but better than what we have now.
And
there you go.
While we're going on these people never or always talk about this, John asked, is geoengineering the only solution today to avoid climate disaster, famine, migration, war, etc.?
Well, and I buy that. So geoengineering technically covers carbon removal as well as reflecting the sun away, a small amount of the sun away. I would say that the thing that, the number one thing people don't know about climate change that they should is that CO2 doesn't go away when you finally stop emitting it. It stays there essentially forever. I mean, not forever, but as far as we're thinking about it, we should just assume it's there forever. So things don't get better when you stop emitting. If you're lucky, they stop getting worse. But even as we talked about today, they probably still get worse. So given that we emitted 2.6 trillion tons and essentially have an extra trillion tons of CO2 in the atmosphere, things are going to get bad, as we're just talking about. 3 degrees of warming is not acceptable, period. It will not be okay in any dimension. And therefore, the only thing that can stop that, I believe, I haven't heard of anything else that can stop it besides solar geoengineering or sunlight reflection methods. I think that the people who say sunlight reflection methods are bad and what we should do instead is just focus our attention on emissions reduction, I think that they're really, really, really optimistic. And they don't really understand that it really can't work. I mean, it's a really good thing to do. We definitely should be lowering our emissions as fast as we possibly can. But it won't stop us from going over 1.5. We've already done that. It also won't stop us from going over 2 because it takes so long to accomplish it. And then the impacts, you don't even notice the impacts for decades, right? And so I think the answer is the only way we're going to avoid going over 2C for sure is with sunlight reflection methods. And probably the only way we prevent going over 3 is with solar geoengineering. You could argue if we woke up tomorrow and decided to reduce our emissions at an incredibly fast clip, go see my 20-point global climate action plan program where we go over the policies that would be needed to phase out fossil fuels. If we did that, maybe we could stay under 3 without geoengineering, but 2 is really bad. So we don't even want to do that either. So that's my quick answer there.
I here's one, and I should have asked this earlier when you were talking about it. We were talking about what the Leon topic, aerosol reductions. What about Wolf asked, what about China's aerosol reductions? That's huge too. Is there anything going on over there?
Yeah,
Sorry?
and by the way, so about China's aerosol reduction, and Zeke Hosfather in his program yesterday that Leon linked a small clip to, he talked a lot about that. Yes, so China's been greatly reducing its aerosol emissions because you couldn't see across the street in Beijing, and that's all PM 2.5 caused by their coal plants, and so they put sulfur scrubbers. And the interesting thing, he told the story, I didn't realize this. He said they had sulfur scrubbers already, but they only turned them on when the inspectors came. And because they do take some energy to run them, and they wanted to have the maximum output, so they they built the sulfur scrubbers but didn't use them except when the inspectors came. But then Beijing, during the Olympics and everything, decided to crack down on air pollution, and then they passed policies and regulations to require them to be on all the time, and so their aerosol reductions have really been very impressive. Ours too were impressive in the 70s. We had this whole problem of acid rain, and we put sulfur scrubbers on things, and so the United States already did that. Europe has done it and is doing it, and now China is doing it too. And I guess the big news out of China is, although it's really hard to say if it's really true or not, but they may have actually this year lowered their emissions for the very first time. Like the actual total greenhouse fossil fuel emissions might drop a tiny bit, which is way better than going up a lot, I guess.
Thanks to Trump, right? No, it's
maybe thanks to Trump. Yeah.
Sorry, Stacey, can you repeat the question?
Oh, just about China's aerosol reductions and
Yeah.
What's going on?
Yeah, so there was even before 2020, there was already quite a lot of research on that, where they showed that the warming would be about 0.1 degrees Celsius, and even more over the northern hemisphere. And of course, there's quite a bit of uncertainty there as well, because as we discussed before, that it's not linear. The effect is not linear. So if you decrease the first half, the effect is less noticeable than when you decrease the bottom half of the emissions. But still, indeed, the emission reduction is really mind-boggling, as is from the shipping, of course. Like from one day to the next, reducing the amount of shipping emissions over the oceans by about 80% is really enormous. And indeed, so they use these scrubbers. What they put in, what they use, they have these, like, from the smokestacks, they put these like rain showers in where they have these huge pumps pumping chalk, so water mixed with chalk, and then goes into a chemical reaction with the sulfur, and that creates gypsum, and this gypsum is sold on the market. And with that, in Europe and in the US and also in China, and of course they have to create these markets for this product. The desulfurization of the air pollution is almost free, because you can sell the gypsum, and you can build stuff.
That's
you can build
the
houses.
Drywall in most modern homes.
Yeah. Exactly. So you can see when this desulfurization at these coal plants started. If you're know anything about the historical changes in how homes were built, and how, like, I think from 70s or 80s, you can see these changes in homes happening, where we have more and more drywall and all these. I think all of us have these drywall gypsum walls here in this conversation, because it's just very, very cheap, because it's just a waste product from this desulfurization, and there's more streams there. And it's the same with shipping. Of course, it does take some energy, but it's quite they just use either they desulfurize it at the the oil refinery, or they use these desulfurization systems on the ship, where they just take ocean water and then flush it through the smokestack and then dump it in the ocean. And then it's also that they take even more than 98 or 95 or 98% of the sulfur out of the emissions.
Okay.
George had a good follow-up to this. India is now talking about aerosol reduction seriously, but considering the heating India has already suffered, they're in a real quandary. Thoughts? And it's Ministry of the Future.
Yes,
yeah.
quick answer.
Yeah.
And I think, Leon, you've looked at this a bit, right? What's going to happen to India?
I wish there was more
reduce
research
pollution.
on that. There's one of the most important research I could find on that was during the COVID pandemic, and I think there was like a 16 watts per square meter increase in sunlight reaching the surface during the lockdowns, which is really like an enormous
Crazy.
effect. And then because India is relatively cool, considering the heating itself, but India is already very hot, and of course there's a lot of extremes. But India is already very hot, but it hasn't warmed very much over the recent decades because of the increase in air pollution, and because of and that's not just from sulfur, but there's a lot of coal being burnt over India. Don't get me wrong, but there's also a lot of biomass being burned, and that also reflects sunlight or causes sunlight to be absorbed in the atmosphere rather than reaching the surface. But what's really important there, and I mentioned that before as well, that it reducing or changing how much air pollution is being emitted over India and even in other areas in the world could really significantly impact the monsoon system. And that's extreme temperatures of 50 degrees are like, some people can cope with that, and they can go inside and they can try to survive that. But if they cannot grow food anymore because these rain bands shift, that will really also have enormous consequences in this region where over 1 billion people live, right? In this North India, where with Pakistan, Bangladesh, India, where a lot of food is produced, where a lot of people live, that can change changing the amount of aerosols and increasing the warming can really shift the monsoon system. And combined with the extreme heat, that I think that's, and I'm really surprised that there's so little research on that. Maybe it's all written in Hindi and I don't read that, but I think I should be able to find it. But they really up for something, I'm sure. But we don't know.
A related question about famine and things is from Nadia. Does the increased humidity capacity cause early foreseen simultaneous multi-breadbasket crop failures, i.e. global famine by dint of genuine shortfalls versus maldistribution? So increased humidity, well, as the planet warms, the atmosphere holds more water vapor, and water vapor is greenhouse gas.
But humidity is decreasing. That's correct. It's quite counterintuitive, but humidity is decreasing because the amount of water the atmosphere can hold is increasing. So the relative humidity, right? So it's the atmosphere can hold more water, and that also means that clouds evaporate faster. That means also that there's more evaporation from the soil, so the soils dry out faster. When it rains, it pours. So that's really crucial in climate. With climate change, that the extremes get more extreme. So when we saw, I think it was 2023, that I think a third of the crops in Greece were destroyed by these extreme floods, the extreme rain events, right? And of course now we have these extreme weather over Spain, but this extreme heat, I think I'm quite sure it's record warm over the around of the oceans that control Europe's weather already for this month, and that will determine for a large extent also the weather over the next month of the summer in Europe. So more extreme weather will, including humidity, including extremes, will cause also, and has already caused in recent years, a lot of crop failures and
And,
coffee
Uh,
price.
and there's
Because we could have a talk, we could have an hour or more about each and every crop that's been affected over recent years.
And speaking of that, one of the favorites of the climate denier community is that CO2 is plant food, and more CO2 is good for plants, as if CO2 is the only factor that affects plant growth. That's the only thing. And yes, in many cases, a little more CO2 is sometimes good for plants, good for weeds especially, by the way, but good for plants. But it turns out that water is a pretty important thing. Too little or too much ain't so good for plants. Heat is usually not good for plants. And you go on and on, and you realize that overall, climate change is not good for our agriculture industry, especially since it was designed over hundreds and thousands of years to work well in the certain regions. And as those regions are now changing, the climates of those regions are changing rapidly, as Leon was just talking about. That's not going to work out too well. By the way, we have 9 minutes. Let's end it on the 2-hour mark here, because we could just keep going forever.
Yeah,
let's a few more here.
I'll just add in my mistake of debating with a climate denier on LinkedIn about this. He posted about someone at congressional testimony. It was actually from 2 years ago, about what percent of our atmosphere is CO2, and had the senator's guess, and it was ranged from 3 to 8%, and then he's like 0.4%, 0.04%.
No,
that's how much
0.04.
Yeah, and it's like, and he said, and below 0.02, we can't grow anything, and I'm a farmer, and blah blah blah, and I'm just like, and somebody, they posted it.
It's pretty funny that he's saying that it's 0.04%, as it's trying to make it so it sounds so little that it's nothing, and then he says, but below 0.02 I can't grow. So he's kind of saying that it's a huge thing. By the way, the reason it's true, it's 0.042%, and that seems like a little number. But it's not the percentage that matters. It's only the amount that matters. And it happens to be 3 trillion tons, and there used to be 2 trillion tons. So it's a huge number. And why is the percentage not important? Because O2 and N2, which make up the vast majority of the atmosphere, they're not greenhouse gases. It's irrelevant how much there is. And the example I give is there's a duck hunt at a park, and there's 10 duck hunters, and there's 10 audience members there, and each hunter shoots 1 duck an hour, so there's 10 ducks an hour that are shot. It becomes super popular, and they end up with 1,000 participants watching, but still only 10 duck hunters. So how many ducks are shot? Still 10 ducks an hour, even though it went from 50% down to 0.1% duck hunters to observers. The observers are irrelevant, and that's also true of nitrogen and oxygen. So that's why 0.4% is a huge amount. And without it, by the way, we'd be a frozen snowball. So, and this whole thing about if it drops, it was 180 parts per million, or 0.018 during the Ice Age, and there were plants during the Ice Age. So it's also not true that you can't grow plants with low amounts of CO2. Anyway, so there. Yeah, by the way, we should probably do another show. I did one show on this, on talking to a denier, so we can go through all the denier myths. But let's try to get more of the serious questions here.
Okay, so this was a good one. Another one from Jean, and it's related probably to the EROI. GDP is distorted by debt and inflation. If a country makes 2% growth with a 5% debt, this means a 3% recession. In fact, GDP should be calculated based on energy consumption. What do you think?
Well, first of all, governments can print money, and most governments can. Well, the U.S. can print money, so it funds.
But then it leads to inflation.
I was just reading about yesterday that it's not that the taxpayers fund the government fund the taxpayers, but by printing money. So I don't know. So that's a whole other non-climate thing to get into. Should we be measured by energy? No, there's a huge difference between renewable energy, carbon-free energy, and carbon-bearing energy. So that alone. And then again, there's all this natural energy. I mean, we grow crops using the sun. Should we count that energy as energy? You know, it is. It's real energy. We're utilizing that for human purposes. We're just not converting it first to electricity. And speaking of that little tidbit, we grow corn because of Iowa farmers. You know, got a lot of political power. 10% of the gasoline is ethanol, which is not as efficient as gasoline. And we use huge swaths of land in the United States to grow corn just for ethanol, not to eat. But if you took half the land of the corn used to grow corn for ethanol only, not for food, and you took half that land and put solar panels on it, you could power the entire United States. To give you a little difference, because it's, think about it, the energy efficiency of converting sunlight to ethanol is less than 1%. I mean, I don't know, it might be a lot less,
but quite high, I think.
It's 2% just to grow things is about 2%. But now you convert the ethanol into energy, and it's probably 0.1%. But solar panels 25% efficient in converting sunlight, and you get to use all of that.
So what really blew my mind when I read about it, it's that, and there's quite some uncertainties in these numbers, but if you look at the total energy used by humanity every year, that's about 600 petajoule, so 0.6 zettajoule. That's about 30% of the global photosynthesis every year.
Wow!
So that's like, it's like really mind-boggling that the order of magnitude is similar to all of global photosynthesis.
Wait a minute, can you say that again? I'm not.
So all
the amount of energy that humans use is it? You said 2/3 or a third?
30%.
So it's about a third of all the energy used to grow life on Earth from this photosynthesis. So that's the sun growing trees and plants and bushes and
algae.
Everything.
So we
around the entire globe, not just human, but the globe, right? And you think about the energy that the Earth is using to grow life on Earth, and we as humans, one species, are using a 30% of that. But that's not all from plants. That includes fossil fuels, right? We're digging up fossil fuels, and we're using that and renewable energy now. So that's an incredible amount of. When you think that, just think of all the energy the Earth uses to grow life. You think that's a pretty big number. And humans are using a number equivalent to a third of that every year. That's a big number. Okay, let's move on. We got 3 minutes. One more question.
Stacey's mind takes a while to be blown here.
Yeah, I'm
slowly.
trying to. I need the visual, the chart that goes along with that, I guess. Okay.
You know what photosynthesis is, right, or not?
Some plants.
Exactly. So all photosynthesis that happens on our planet in a given year, all that energy, we use about 30% equivalent of that every year.
Okay.
All right. So what we got here?
Ants burning stuff and
maybe. By the way, I think we have Eli. Let's turn on Eli. Turn on your mic. You had some other questions, so maybe I'll let you go with the last question. I don't think we answered one of them, but not the other one.
So, so this is from one of our regulars when we were on Clubhouse, and it's to Leon. This is kind of, taking a step back and looking at the big picture. What are the policy implications of the work you've done on global warming in the pipeline? What are the most important studies other than your work with policy implications that people should know about? And what are their policy implications?
I think, of course, I think many studies come to similar conclusions as we came, especially in global warming in the pipeline, that, of course, we have to rapidly reduce greenhouse gas emissions. We have to really start to consider aerosols, especially for regional climate, right? That's That's also what during the European Geosciences Union was a crucial subject, where as I highlighted, that people need to prepare for these rapid changes in the monsoon, these rapid regional warming, right? And I think that's very much about policy. How if you, for example, for our regional governments, how high do our dikes need to be? How much water do we need to store in our water reserves? What are the heat plans in for Spain? Right, all these and that's where you need to start now, because we have these rapid changes which are not accounted for in many regional climate models. We need to start to include them, and people need to uh, be aware of it and adapt, and then start to mitigate, and also start to discuss what are the implications of this rapid reduction in air pollution for our regional climate. And then what we are starting to see is that more and more people are starting to ask for intentional cooling, sunlight cooling, and I think that's one of the reasons. What we propose is that we need to research on these sunlight reflection methods before rogue agents or governments or Elon Musk or whoever it is starts to do it without this research being in place. I think that's also relating to some individuals pretending to act as climate scientists, but opposing and calling for objecting any climate research in this field. And I think that's really, really dangerous, right? Because if we don't have the research in place, and some are even objecting aerosol research, which is really stupid. But if we don't have the research in place, that's what comes with the most risk. If rogue agents or again others start to do sunlight reflection methods without all this research having been done there, because there were some individuals saying we shouldn't do this research. It's really mind-blowing that there's scientists saying that there shouldn't be scientific research on a certain topic, right? Because they don't like it, right? Nobody likes to do it, but we need to have it in place when some others think about even consider doing it, right? Because if it's too risky, we shouldn't do it. Okay. And I can talk about it for more longer,
but we have come to the end, and so this is the first time we did this on YouTube, and I think it was pretty good. So we'll probably have to do this again, maybe once a quarter or something like that. But keep in mind that this Tuesday at 10 a.m. Pacific time, we have a special guest, University of Michigan Professor Caitlin Ramo. Ramey. I'm sorry, Ramey. I didn't have it in front of me. Ramey, and we're going to be talking about public perceptions of climate change and of climate solutions. It's going to be really interesting. I heard her give a talk last week. Really interesting stuff. So be there for this special day, and we'll see you then as our next talk. And we have some other cool stuff coming up too. Please we don't talk about it enough. Like I watch other YouTube videos and they're spending half the time talking about, please like and subscribe. It's important because we're trying to get the word out on climate change to people. And you can do your part by hitting like, hitting subscribe, and also hitting little bell notifications so you find out when we have these little special programs on Tuesday, for example. So
there you
do
go,
all
Jean.
of that and you'll be doing your part. What was that?
Jean was asking, how do we get more people to listen? I guess I should have asked that as the last question, and it's like and subscribe.
And you can share.
Yeah, we have a certain number during the live stream. We get far, far more on the recorded, by the way. So there's that. And but even that, we still need your help in that. So please help us out, and you'll be helping the climate out at the same time. And that's why we're here. We're doing it for that, to help educate people about what's really going on. So thanks, Stacy, Eli, Leon, and everyone who asked questions. And sorry we didn't get to all of them, but we'll see you in a couple of days. Thanks for coming, everyone, and we'll see you next time. Bye-bye.
Bye-bye.
Thank you.